See Lindelof videos, operations on functions. So this is a question I keep getting, and I guess we'll just keep going over this until I get this right. Just want to go over two quick problems. So start with this. Let f of x equal 1 over x plus 2, and let g of x equal x over x minus 1. And we're asked to find f plus g of x. I would normally have written this f of x plus g of x, so this has the same meaning, but I see sometimes in some textbooks it shows up this way, so here's one understanding or the other. What I'm going to do is this. I'm going to simply set this up. I'm going to do what it asks me to do. I'm going to add f of x plus g of x. It says here clearly that f of x is 1 over x plus 2. It says that I'm to add them, so I'm going to add them. So here's my plus sign. And I'm going to add g of x, which clearly says that g of x is x over x minus 1. Okay, so it gets a little bit weird here, and I get it. People kind of get freaked out. They're not sure what to do. We have these two functions, and they don't have common denominators, so how do we add them together? Well, I'll suggest to you this, and I hope I don't offend you too badly, that we kind of have this. We have this 4th grade math problem that's 1/3 plus, I don't know, maybe 1/5. And if we were going to add these two numbers, it would be similar to adding these. Everything has to be arithmetic, so it can't be some magic part, right? Here, what we find is we look for a common denominator. One way to cheat on that would be just to multiply the denominators and say, well, 3 times 5 is 15. We can get a denominator of 15. So what would you do? You'd use the denominator of the left side to come up with the multiple for the right side. And remember, it's 3 over 3. It's 1. We're multiplying by 1. That's why it's okay to do it, right? It's 1. What will we do here? We'd use this denominator to come up with the multiplier on the left-hand side. Hopefully you can see where I'm going. I'm not going to paddle through all this math, but you can see now that we'd have 5 times 3 is 15, 5 times 3 is 15. We'd have 15ths here. This bit of 4th or 5th grade arithmetic drives how this is done. So I'm going to do exactly the same thing that I did up there. I'm going to say that my common denominator is going to be this denominator times this one. So what am I going to multiply this by? I'm going to look over here and say I have this x plus 2 here. So I'm going to take that x plus 2 over x plus 2. I can hear your elementary school teacher or your middle school teacher or whoever it was that said, whatever you do to the numerator, do the same thing to the denominator. I guess that's true enough, but the reason is that it's 1, and 1 is the multiplicative identity. So I want to be kind of clear about why we do it that way. I'm going to look at this side. I'm going to look over here at this x minus 1 to help me to figure out what I'm going to multiply the left-hand side by. So I'm going to multiply by x minus 1 over x minus 1. Why did I do my parentheses different than this side? Because whatever. Yeah, no reason, sorry. So I'm going to keep moving. If you don't mind, I'm not going to multiply this bottom part out, but I know that x minus 1 times x plus 2 and x minus 1 times x plus 2 are the same denominator. So if we were going to add these things together up here, these 15s together, we wouldn't add the denominators, we just carry them, right? So I have a denominator of x minus 1, x plus 2. What I am going to do here at the top is I am going to clean this up a little bit. So I'm going to do 1 times this x, 1 times this negative 1, which gives us x minus 1. This is positive x here, so positive x times x is x squared, so plus x squared. X times positive 2 is plus 2x. Yeah? I'm going to go down and say, I'm going to clean this up, just a little bit of algebra here, if you don't mind. A little bit of algebra here, and I'm going to do that, and I'm going to say I have, we have this x squared, so we have x squared. We have 2 x's here, 1 x here, and that gives us 3 x's, doesn't it? And this negative 1, so minus 1, all over x minus 1, x plus 2. All right? All right, so that's what I got. Now your professor or your teacher wants to know the domain, so I'm going to say, well, the domain of this function is, and all you have to do when you have a rational function, is look down here. Remember that a, any number a, over 0 is undefined. It makes no sense, and we can't have that. That's what causes domain issues. So I'm going to say, what numbers would cause the whole denominator to go to 0? Well, if x was 1, if x is equal to 1, you'd have 1 minus 1 is 0, and 0 times this would be 0. That would give us this, wouldn't give us that 0 here. So undefined. So the domain is x cannot equal 1. And what if x was negative 2? We'd have negative 2 plus 2 is 0. 0 times any of this mess would give us that 0 at the bottom again. So x can also not equal negative 2. Some professors would rather you write it this way, and they'll write domain like this with a weird looking d like that, and they'll write x such that x does not equal 1, x does not equal negative 2. So I hope this was helpful. The next video I'm going to do is this one. I'm going to do f of g of x, and how do you find the domain doing that. So hopefully you'll look for that video. Thanks so much for watching. If you have any questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks.